Welcome back to the tutorial series on gravity data processing using the DGS MATLAB applications designed for data acquired using the DGS 81E meters. In this video, we'll explore how to calculate cross-coupling corrections, which are important for minimizing leveling errors at line intersections. In the previous video, we covered how to import data into the line crossing tool window. Now we'll proceed with calculating the cross-coupling coefficients. Before we start, I should mention that in order to demonstrate the improved performance of the level compensation and cross-coupling correction, the test data that we imported in the previous video was selected with some conditions in mind. One is that this survey was done with a very small airplane. The survey was done using a draped trajectory. The flying conditions were highly turbulent and the survey lines were very short, sometimes covering a distance of one platform period. Now let's go ahead and calculate the cross-coupling gains. To do this, we'll use the calculate menu here. The calculate menu is the primary interface for most of the processing functions in this tool. To get started, we'll click on the grid mistypes menu here. Once you click it, you will be prompted to decide whether to apply the calculated corrections to your data file. For a first-time process, I recommend selecting no by inputting N, as it's generally better to assess the corrections and then iteratively recalculate them if needed. So I will leave it as N. Next, you'll be asked if you want to save the calculated cross-coupling coefficients or gains to a text file. So it saves it to a default text file labeled as ccgains.txt, and it will be saved in the same directory where you imported your data from. So for now, I will not save the coefficients as I prefer to assess them first. So I'll click no again by inputting N. At this point, the software has already calculated the cross-coupling gains from the input data, and I can see them listed here in the CC gains panel. It's also important to note that the process log panel here will display the total number of intersections. So here we have 420. We also have the mean absolute error here, which is before any correction is applied. The mean absolute error of the intersection is 13.443 milligauss, which is quite high. And then the mean absolute error after applying a cross-coupling correction only comes down to 4.9799. And then we also have the error after applying only a DC adjustment. So a DC adjustment is simply a zero-order leveling method that simply adjusts the data by averaging the intersection errors along each line and adjusts the lines by the average of the errors. And then here we have the mean absolute error if both a cross-coupling correction and a DC adjustment is applied. So here we have 2.34 milligauss, which is significantly lower and better than 13.4436. So that's a big improvement on the data. And that brings us to the end of this video. In the next tutorial, we'll focus on assessing the results of this calculation and how we can proceed based on those assessments. See you then.